Alright, we're going to look at the different stages of mitosis. And remember that mitosis is the division of the nucleus. We are separating out all of our chromosomes so that we can form two new cells. The first part of mitosis is prophase. Prophase is the initial phase of mitosis. Remember, pro is like 4, so this is all 4 getting things started for mitosis. A lot has to happen in prophase. Our DNA needs to coil up. Remember that long stringy DNA isn't going to travel very well, and we need to package up our DNA so that we can move them into their two new cells. So they're going to coil up into those visible chromosomes that we see in the center of the cell. The other thing that has to happen is we got to lose the nucleus. The nucleus is just going to get in the way of moving our DNA. The nucleus's membrane's whole job is to protect the DNA and keep it separate from the rest of the cell. And it's got to leave. It's got to go away so that we can actually physically move our strands of DNA, those chromosomes, away from each other. And the next thing is our centrioles have to go to work. Those are our little cowboys that have just been sitting in the cell doing nothing, and now they need to get ready for the rodeo because it's going to be their job to round up those chromosomes, separate them, and pull them into two new cells. So part of that job, like any cowboy, they got to have the right equipment, and they're going to need spindle fibers to do that, and those spindle fibers are going to act exactly like lassos. They're literally going to lasso those chromosomes like they would a head of cattle and pull them around where they need to go. So let's look at that. Here you can see the centrioles getting in place, spindle fibers are out, and they're grabbing hold of the chromosomes once they're free of the nuclear membrane. The next phase is metaphase. Think of M for meta and M for middle. Once the centrioles grab hold of the chromosomes with their spindle fibers, they're going to line them up exactly in the middle of the cell. Now those spindle fibers are attached to each chromosome by their centromere, and that's like the little anchor point. And remember that centromere is basically serving as a staple, pinching the two identical chromatids together so that when we separate them, each side's going to get an exact copy of the original DNA molecule. So think M for middle, M for metaphase. One tidbit is now that the cell is sitting in such a way, we can describe it like a globe, where the two ends where the centrioles are sitting are the poles, and the chromosomes are lined up along the equator or the central plate. But they're in the middle of the cell. M for middle, M for metaphase. So let's watch that one too. There they go, right to the middle of the cell. The next part is anaphase. Anaphase might seem like a crazy part, but think A for Anna, A for away, or A for apart, because the chromosomes are going to get pulled apart and move away from each other. So this is where the centrioles are going to start shortening their spindle fibers, and they're going to start pulling the chromatids apart. They're going to separate at the centromere where they were being held together, and they're going to start being pulled to opposite poles of the cell. And it looks a little chaotic, but you can see it here. You'll have to be patient. This next video takes a little bit of encouragement to get going. And there they go, being pulled away from each other to opposite sides. So A for Anna, A for away, and apart. The next phase is telophase, and telophase looks like serious business because there's actually two parts going on with it, and for telophase there's a lot of things being accomplished in it just by itself. Telophase and cytokinesis, and remember cytokinesis is part of the cell cycle, tend to run together and they happen quickly. So like I said, it seems like there's a lot going on. But we're going to focus on telophase at this point. Telophase is just the opposite of prophase. So for everything that happened in prophase, we've got to undo it in telophase. And the other day I had a student come up with a clever way to remember telophase. they thought of teleportation, like you're being teleported back in time. So we're just reversing all the events from prophase in telophase. Another thing to remember with telophase is T for tele, T for two. I should see two new nuclei forming to tell me that I'm going to get my two new cells out of this division. So the exact events that are occurring in telophase is my nuclear membrane that completely disappeared in prophase is coming back. Strange thing is, we really still don't know where that nuclear membrane goes or how it knows to come back, but it does. As the nuclear membrane is forming, all of your DNA inside is going to start to unpack. It doesn't need to be coiled up around the histones. It doesn't need to be in that tight package form of a chromosome. It can relax now because, hey, it made it to its new home. And then those centrioles are cowboys that, worked really hard for us during reproduction of the cell, can actually go back and hang out and basically do nothing until the next time we need to do active cell division. So those are the three things that are occurring. We're reversing what we saw in prophase. We're time traveling, teleporting back to our original state of the cell. I should see two nuclei forming. The other thing that you'll see in this diagram in the next video is cytokinesis taking place. Remember, cytokinesis is actually just a physical separation of the cell so that we can get two new cells out of it. So here we go. There's a cleavage furrow that would form in an animal cell, and we would be seeing a nuclear membrane forming on this end, and then these DNA molecules would relax, and then the centrioles would just go back to hanging out. So that's mitosis, and if you need to, you can review this video again. There's also some additional resources on the blog that you can view to help you out, but you're going to have to give yourself time and opportunity to study the diagrams and definitions for each of those phases. There's flashcards available to you, and if you need more help, make sure you check in with me so that you can get those 4 parts of mitosis under your belt. So in with the cell division, in with the cell cycle, there are different checkpoints to kind of make the cell stop and think, hey, are we okay? Are we good to continue to divide? And in interphase, there's a couple of checkpoints that we want to pay attention to. One checkpoint is the G1 checkpoint. At that checkpoint, the cell is going to say, yeah, we did our job. We've got enough organelles. We've got enough nutrients. We've got enough stuff that we can divide and there shouldn't be any problems. So if we get the green light for that checkpoint, we're going to move on to copying our DNA and moving into the G2 checkpoint. The D2 checkpoint is to double check our DNA replication and repair or fix any errors that may have occurred during DNA synthesis. If we get the green light at the G2 checkpoint, remember we're going to move into mitosis. In mitosis, there's no going back. We just go through all 4 of those phases, prophase, metaphase, anaphase, and telophase until we're done. And when we hit telophase, there's a mitosis checkpoint. And this checkpoint is very critical because if it decides that, hey, we have successfully divided our DNA, we're good to call this division finished, then mitosis will signal we're done and we'll go back into the interphase process and the cell can just be a cell. But if for some reason mitosis doesn't get that stoplight to say, hey, you're good, you're done, we can go to interphase, it's going to keep a green light and it's just going to keep going through mitosis. And if that occurs, the cell has lost control of its cell growth. It has lost control of cell division. It's basically mitosis has gone crazy. And when that happens, cancer cells are formed. And we were going to look at cancer cells specifically for Learning Target 5 later, but I wanted to start that conversation here when we look at mitosis and cell division. So here's a quick video for you to kind of recap those different parts of mitosis. Alright guys, again, it's going to take some time, but if you have questions or want some further resources, don't hesitate to see me.